All right, let's talk about web servers. So actually, let me introduce the homework a little bit. Let's talk a little bit about homework 2. We're getting into homework 2 content. Monday was kind of like a one-off lecture, just talking about front-end stuff. We're going to use some front-end stuff moving forward, including in today's lecture, but there's more just background. So let's talk about what we're actually going to do in homework 2, and the big answer is file uploads, or image uploads specifically. So we want a website that isn't just going to sit there and host our content and host it for people to see, what I like to call poster sites, just pinning a poster up on the internet. We want a site that actually has some interaction with our users. So we're going to let our users upload files with comments, effectively images with comments, effectively building an image board site. So you post an image and a caption next to it. Somebody can reply with an image and a caption. That's what we want to build here. So that's what we're building through homework 2. Learning objectives 1 and 2 are going to build that functionality. Then we're going to add some extra features onto it as we move into the application objectives, handling arbitrarily large files with possibly some strange characters in it. New lines especially. A lot of y'all like to get a request and then immediately do split on /r/n. What if that byte is part of your image? We'll talk about that a lot next week. Maybe Friday. When do we get to that? Cross-site request forgery tokens, plugging up a security issue, a security concern. And then polling, being able to see new images as they're posted instead of having to refresh the page to see any new posts. So that's what we want to build with this homework. And let's, did I hit escape there? And let's build that. So first, kind of another one-off, actually, because I removed query strings from all the homeworks, but I still want to talk about them a little bit, because it leads in nice to the next thing I want to say. Query string is going to add extra information to the URL of a request. And you'll get these query strings right in the path in your request line. You'll get the entire query string, and actually the fragment too, but I don't have any slides on fragments. And you can see these query strings around the internet. If you make a search on probably any search engine, they're going to use query strings to encode your search. So if I go to Google and do a search for web development, I type in the search bar, web space development, it's actually going to fire off a GET request for google.com/search ? Which starts a query string, and then a series of key value pairs separated by ampersands, and each key and value separated by an equal sign. So I have Q, which is short for query, equals web plus pluses instead of spaces, development. And when you search for web development and hit go, that's actually what you're doing. All that text box does for you is formulates your URL and adds the query string into your URL. You can do the same search just by typing right into the address bar, whatever your search query is. I don't know why you would want to do that, but you could potentially. Or if you're writing a script to make these requests, you could just write these requests manually without using the search button at all. And if you want to add extra parameters to that, if you only want image results, you would add a second key value pair, IA, I don't know what that stands for, equals images, and that'll do an image search for web development. And I do actually talk about fragment. Fragments are useful. I thought I removed these from my slides, but I'm glad they're here because I like talking about fragments. Fragments will help you navigate to a specific portion of a page. So for example, this URL Wikipedia page, if I want to send this link to somebody, and I want to say, just send them what I use, the definition section. I'm interested in sending somebody the definition section of this Wikipedia page. I can just send them the link to the page and say, scroll down to the definition. That's the part that I'm trying to show you. I could do that, or I have a fragment of definition which tells Wikipedia to scroll down. As soon as you get to the page loads, immediately scroll down to definition. This should be an actual URL that I can click. So It'll load the page, and of course it didn't work. Of course it didn't. So they might have rearranged the sections, maybe. No, they just rebuilt this whole, because they rebuilt all of Wikipedia, didn't they? Well, okay, let's grab this section. So I want to go in these links. So Wikipedia, they built the page to use these fragments. So when you click on one of these URLs, one of these links, and then grab the URL, and you send that to somebody, you can send them a direct section. It scrolls to that section of the page. You can also do this with PDFs. PDFs support fragment page number. So you can send the PDF. You got some 300-page PDF that you want to send to somebody and say, go to page 102. Just send them a URL with the fragment for that page number, and it'll immediately scroll to the page that you're interested in. So it can be a convenient thing as a user. We're not going to build our web servers to take advantage of this, but it can be a useful thing just as a consumer of the internet to be able to send those. I find that actually useful from time to time in my life. Just sending someone a link that is just more directed. This is exactly what I want to show you. Or just saving my own links for my own purposes. I'm sick of scrolling every time. I use the fragments. So query strings, a question mark indicates the start of the query string, and then I already said this on the previous slide, but key value pairs, each separated by ampersands, and each key and value separated by an equal sign. So Q equals this value, and IA equals this value. Since these are in the request line, they're part of the URL, in fact, ASCII-only characters. So anything in the request line in the headers of HTTP, it's all ASCII only, so only ASCII characters in URLs. You can't have a non-ASCII character in any URL ever. It's just not allowed, or else things break. What's up? Were you waving me? Oh, I thought you were. I thought there was a question in chat or something. Oh, if I'm logged in, I don't know if I want to log in. Then I'm going to have to re-log in I don't know. Internet's so convenient, but there's these little things that are just starting to needle me to death that are getting annoying. I don't want to create an account on every single page I go to. And if we want non-ASCII characters in our query strings or in our URLs, we can percent encode them or URL encode them. So if you've ever seen, so we can do our percent and then the bytes, and this will be the way that we represent any hex values that we want. And if you've ever seen this %20 in a URL, that's the ASCII encoding percent or URL encoded ASCII value for a space. So if you have a space somewhere, it's usually replaced with %20, or as we saw in Google searches and in search engine searches, they end up replacing the spaces with pluses, just to be different, I guess. But our spaces can be percent encoded to %20, because we can't have spaces in URLs. It's just not allowed. That'd be crazy. The whole world would start on fire. So %20 to encode that. And spaces usually indicate multiple values at a key. So it's usually, if we want like an array stored in a key, we would use pluses. But as we see, the search engine uses pluses to have, I guess, an array of words. Maybe that does make sense in that context. But they use pluses to replace your spaces in there. But in general, pluses are to indicate that you have multiple values at the same key, like a data structure, kind of a data structure. And we have a certain number of reserved characters in our query strings and in our URLs in general. Each one of these characters has a special meaning. A lot of these we've seen, like ://, that's part of the structure of a URL. You have your protocol, :// host, :port, /path. That's part of it. Ampersand is special to query strings. The hashtag indicates the start of a fragment. Question mark indicates the start of a query string. So none of these characters, I'm not going to go through all of them. For some of these, I forget what they are. But these are all special characters in URLs, so they can't be used as part of any of your paths. They can't be used as your domain name. They can't be used as any of your subdomain names. They just can't be used anywhere. In your query strings, in your fragments, in your paths, none of those. I think I already said paths. Can't use these characters. They're reserved characters. They have special meaning in URLs, so you can't use them. But some notable exceptions to this, because it's like most of the special characters we would use, of the ASCII special characters. But some notable exceptions, dash, dot, underscore, and tilde are not reserved characters in URLs. So we have full freedom to use these. And you see these a lot in URLs. If you're ever wondering why you see so many tildes in URLs, the other ones are kind of not too special. But you see a lot of tildes in URLs if you're really paying attention to that kind of thing. But you don't see really any other special characters. Well, I guess you do, but they have special meaning. I guess if you don't know they have special meaning, you wouldn't notice so much. But we see a lot of tildes because that is not a reserved character. So it's a special character that we actually get to use in our everything, in our stuff. Our paths mostly is where we would use it. Our paths and our query strings and our fragments. So that's all. That's the end of my sidetrack into query strings. Any questions about query strings? I don't ask you to do this on any homework, so I would love to have questions. So that means you're actually interested. But there's also not many questions to ask, I don't think. Like that's everything to do with query strings. Okay, let's move on to forms. Let's get into the juicy bits here. So we want dynamic pages. Right now we just have poster sites after homework 1. Homework 2, we want more dynamic pages. Ultimately, we want our users to be able to interact with each other. That's really most web pages that you go to. Like, that's why you go there, is because users can interact with other users. Even if you're just going to lurk, even if you're not interacting yourself, you want to watch other people interact. I go to Reddit just to read things and read people interacting with each other, even if I don't post anything. Like, that's what we want in our web apps to make them actually interesting, is user-to-user interaction. So starting with homework 2, users can upload images and see all of the images and comments that other users uploaded. That's what we're after. Without that, the internet just isn't that exciting. Even email is like that. Email, if you can't interact with other users, who are you going to email? So let's talk about HTML forms. And this is why we talked about front end when we did, because we're going to start using some HTML elements, and I just want you to understand what attributes and all that are, elements, that good stuff, because we're just going to use them like you've known them your whole life from now on. So we want to build an HTML form. I'll talk briefly about each of the inputs here. And we want this form to be able to send information to our user. Here we have 2 text boxes, so a little bit different than the code that I give you for homework 2, where you're going to have a file upload and a comment. We're not quite ready for file upload yet. We'll get there on Friday. So we're just going to start with 2 text fields. So this is an HTML form. It's a special HTML element type that's going to let us fire off HTTP requests right from the HTML. So when we click submit right here, obviously not on the slide, but I clicked it anyway. When we click submit on this form, it's going to fire off an HTTP request to our server. Then whatever our server responds with, the page is going to reload with that content. This is how HTML forms work. Oh, slide, I just said that. God, keep up. So let's break this down. We're going to have a form and then several inputs. The form is going to have these 2 attributes to start with, at least. Action and method, these are the 2 required ones. Actually, they might have, bless you, they might have defaults, now that I say that. I don't know. I always specify them. I don't care if they do have defaults. But action, bless you, this is the path of the request that's going to be fired off when you click submit. So when you click submit, it's firing off an HTTP request. So we need 2 pieces of information, the HTTP method and the HTTP path. So path is going to be action. I don't know why they didn't just call this path. Don't ask me. I think it's because you can call JavaScript here. Is /form path. So this is going to create an HTTP request where the request line is going to have the path of /form-path. And it's going to be a GET request. So when I click this, that's what we're going to see on the server side. We're going to see a GET request for /form-path. And then we need some inputs. There's no point in having a form if we don't have any inputs. Inputs are anything that the user is going to interact with and input data in, or click, as we see with the button. So input, a couple of things here that are important. Type is going to give us the type of input. Text is just going to give me a good old text box. That's all I want. I want people to be able to type in their name and comment in this thing. So I'm going to have it be a text box. Name, very important. Name is going to be the name that the value is going to have when it's sent to your server. So when somebody submits this form, we know we're going to get requests on form path, but the information that is sent to us, we're going to have two pieces of information, and we have to know which one is which, and we're going to know by the name that we give it here. So we're going to get a value with the name of commenter and a value with the name of comment, and that's going to tell us which value corresponds to which text box. So adding names to your inputs, very important, and then very important that you're consistent. On your server, you're expecting the same names that you put on your front end. So that's how your front end and back end are communicating, is through these names. And then maybe the most important, or maybe the easiest to forget, I don't know. It's important, is to add a label to each one of your inputs. So this is important for accessibility. People with screen readers can't tell that this is a text field, they can tell it's a text field because they can read the typed text. They can have a screen reader read that. But they can't tell that enter your name corresponds to this box necessarily. If somebody's blind and accessing the internet through a screen reader, they can't tell that that text corresponds to that input. We can tell because just the way things are laid out visually, if you can't see, you can't tell. So if we add this label with a for, which matches the ID of the input, we're explicitly saying this label is for this input, and this is the text of that label. So now with the screen reader, they can say, enter your name is the text that's associated with this text box, and then they can actually use the internet, which is nice. There's another practical reason for that, aside from accessibility issues. I guess this is still an accessibility issue, but affects everyone, is if you have this label is inherently associated with that input. So if I click the text box, of course, that text box becomes focused. But if I have this label, this text is a label that's for this text box, I can click on the text here, and it'll focus that text box, which is handy, I think. Especially with radio buttons, has become one of my pet peeves, and it's just exacerbated by the fact that I know it's an accessibility issue as well. When I have a bunch of radio buttons, which are the circle buttons, if you're not familiar with the name, if I have like 5 of those, like for the lecture questions, you got 5 radio buttons, and then there's text next to them, which is just A, B, C, D, E for the lecture question, so it's not as helpful. But if you click that text, it'll select that radio button. That's something I've kind of gotten used to with the internet. I can click the text. I don't have to get my mouse right on that little circle. I can click the text that's associated with that radio button. And that's because the label is set for that input. So that's set on the lecture question. You can click on either the letter that you're choosing or the actual button next to the letter because I have my labels set up for those inputs. You should do this. You should always do this. It's just helpful. It's just a good way to set things up. And pretty standard, and I'm pretty sure there are laws that say you have to do this under certain conditions. So just get in the habit of doing this. There's actually approving TA timesheets. They don't have a label on the checkbox that says, I approve this thing. I have to get my mouse in that little circle every single time. It's a little thing, but I sign on enough timesheets that it gets frustrating. And the fact that UB doesn't add their label for their input is frustrating on another level, too. All right, enough of that. For more front-end stuff like that, and much more, take CSE 370. You'll talk about all that. But that's one that's so important that I even slip it into this back-end course. That sentence didn't come out the way I wanted it to. And then finally, we have an input of type submit. If you have an input of type submit, that gives you a button, and the value of that button is going to be the text that's on that button. I can put whatever I want for value, and that'll be what's displayed on the button, but the type has to be exactly submit. That tells the browser, hey, give me a button. And with type submit, that being inside a form like this indicates that, hey, when this button is clicked, I want all this information to be packaged up and fired off to the server. And that's our first HTML form. It's just a little bit of a problem. Depending if this is a problem for you or not. I'll make it a problem if it's not a problem for you already. When you fire off, if you use this form exactly as written, it's a GET request, so there's not going to be any body to the request. So all of the information doesn't really have any place to go except the query string. So this will be percent encoded. If I input these values and click submit, it'll be percent encoded and set as key value pairs fired off as part of the path being the query string, as a query string, and then fired off to the server. So I get form path, which we expect. It's a GET request, which we expect. And then question mark to start the query string, name, commenter, I put in Jesse, so equals Jesse, and comment, the name that I put here, equals good morning, percent encoded. And my browser did, when I ran this, I actually submitted and saw what it did. It actually did replace my space with a plus instead of a %20. But my exclamation point, that is a reserved character, so it got percent encoded to %21, its ASCII hex value. We're not actually going to do this. I told you we're not even using query strings, so we're not going to do this. We want another option. So let's have another option. And in fact, we can't do that. So I said, I'll make it a problem if that ain't a problem for you, which it's just kind of gross too, just throwing all that data in a query string. We have some actual issues too. What if we want to upload a file, which we do? That's what homework 2 is all about. What if we want to upload a file? Are we going to get all the percent encoded bytes of a file in our query string? What if that file is a gigabyte? What if we're uploading a video? We got a big old MP4 that we're uploading. What if it's even just a megabyte? So there are a few issues. One, it's just gross. But two, browsers and servers often have a limit to the amount, to the size of the headers, including the request line, which includes the path, which includes the query string, which will include all your form upload stuff. There's typically a limit, which is only a handful of kilobytes. So even if you wanted to do this and said, I'm just doing everything through query strings, screw it, you're going to be limited to several K. Like if somebody wants to upload a 100K image, which is a pretty small image these days, usually you want to be in at least the megabytes range, they just can't do it. You can't do it. Can't use this. Not practical, not very useful, just can't do it. We need a better option. Enter post. Post is going to be our savior for this. So with post requests, that's when we're actually going to, this is the request type we use to send information to a server as opposed from getting information from the server. And when we send post requests, we saw this if you did the end of homework 1, or if you're doing the end of homework 1, you'll see this. But if not, let me just quickly refresh. Your post requests, any post request sent to your server is going to follow the same format as your responses, meaning they'll have content length and content type headers. They're guaranteed to have those because if you have any content in the body of your request or response, you have to have those two headers to tell either the server or the browser a bit of information about what that content is. How many bytes are there, and what's the type of this content? How should it be read? How should it be parsed? So you'll see those things in the same format as your responses. Excuse me. So when you are parsing a post request, you've assembled these as responses before, but when you're parsing a post request, We got to be on the other side of that coin. So homework 1, you got used to sending things in this format. Homework 2, you're receiving things in this format, and you got to do something with that stuff. So your steps are, first, look for that blank line. That blank line has to appear in every HTTP request and response. Even if there's no body, you put that blank line there, the /r/n/r/n. That blank line has to be there, even if there's no body, to indicate that there is no body. Once you find that blank line, then you can you can separate the headers from the body of the request. This is the same thing the browser does with your responses, which is why if you have like your redirect, especially, I think is where we see it the most. Yeah, your redirect, because that's the one response with no information, with no body. When you send your redirect, if you don't have that trailing /r/n/r/n, that blank line, if you don't have that at the end, the browser's going to hang because it's still trying to read headers. It still thinks you're going to send it more headers, because until it reads that, it doesn't know that it's done reading headers. It doesn't know you're done sending headers. So it's waiting for more headers to be sent. So that's one of the common issues in homework 1. On the redirect, not having your trailing blank line. It has to be there. And now that you're writing parsing code, in homework 2, you're going to parse and look for that. The first thing you do in your parsing is going to be, not necessarily the first thing, is going to be looking for that blank line. Well, if that blank line doesn't exist, your code's going to break, right? It has to be there. It's part of the protocol. It's guaranteed to be there, so you can rely on it being there. Then you're going to read the content length. I'll talk a lot about that on Friday in next week. I'll save a lot of that conversation for later. But you want to read that value, and then make sure you read that many bytes in the body of the request. So we're going to update our form to actually send off these post requests. We're just going to change the method to post, right? Done deal. All right, we did it. We changed the method to post, and now this form is going to send post requests instead of get requests. Done. Kind of. Still a problem. When we send off a post request like this, we get the same exact query string, or more specifically, a URL encoded key value set of key value pairs. It just goes in the body instead of the URL. That's the only difference. It's not a query string anymore, but the same exact text just gets slipped into the body of the request. Not really what we want. So we do get content length. We can see these. These are the values we'll get for content length, content type. Content type is going to be URL form encoded. I said those in the wrong order, but it's URL encoded form inputs. So meaning, most importantly, it's URL encoded. It's encoded with percent escaping, key value stores, the same part as the query string. I already foreshadowed the content length stuff a little bit. So it's not quite what we want. It's not terrible. Slide already say about images? No. Slides don't want to tell me yet. But it's not terrible, right? You got to deal with percent encoding, but we could find a library to handle that and URL decode our stuff and get the values that we wanted. We could do that. But there's one huge issue with it. Even if we wanted to go through that and parse your URL encoded inputs like that, you can't upload images like that. You just can't. Can't upload images. The browser just won't do it. You can try. You can set this up. You can set up the form from the homework where it's going to have this multi-part form data, which you'll be spending like the next few weeks of your life on and agonizing over, which is the end point here. Without that, you can take the form from the homework and change this, just get rid of the encoding type, and try to upload a file. What you'll get is, in that URL encoded string, is you'll just get the file name and not any bytes of the file, not the actual contents of the file itself. You'll just get the file name. So if we want to support file uploads, which we do, we have to use multi-part form data, or I shouldn't say have to so strongly, or We can use something super duper fancy, stuff we'll learn later on in the course. But for now, if we want to use an HTML form like this and not get super sophisticated with it all, this is the way we have to do it. We have to use multi-part form data as our encoding type. So we're going to specify our encoding type, the way that our data will be encoded before it's sent off in this request, and we're going to specify multi-part form data. For encoding type, there are actually only 3 options. The default is that www-form-URL encoded. That's the default. You can specify that explicitly. You can say encoding type equals that and specify that. There's multi-part form data, which we're going to see and talk about a lot. And there's text/plain, which even the official documentation says don't ever use that unless you're just straight up debugging stuff. It doesn't encode anything. It just throws everything in plain text. Don't use that one. It'll break on lots of different cases. Don't use it unless you're strictly just debugging and you know exactly what you're doing. So the encoding type has to be multi-part form data if we want the contents of a file. If you've ever done web development before and you're working on your server, you want to support file uploads in any fashion, and it didn't work and you were getting frustrated with it, and you finally found that one Stack Overflow post that said, oh, you have to add this to your HTML form. That's like fundamentally part of how things work on the internet. You have to have that or else you don't get the data of your file. So then you would type this in your form, and then your framework would actually get the data and everything would be fine. But it's a frustrating bug to see at first because you just didn't have this on your front end. This has to be there or else files aren't being sent, period. It's how the browsers work, it's how the specs work, how the protocols work. Okay, so what is this format? So when we get a post request that's multi-part form encoded, we get this monstrosity, which in Friday's lecture I'm going to walk through step by step how I expect you to parse these things, which there are a lot of steps. It's pretty tricky. But this, I'll do the quick overview right now. This is what you're going to get. Post form path, we saw that. Content length is the total number of bytes of the entire body of the request. So this is going to be 252 bytes that I have highlighted. And then content type is multi-part form data, and then a semicolon, meaning we have some extra information. We have another piece of information in this header, and that's a boundary which equals some random value. Random to us. I mean, it's deterministic, but actually, is it? Technically, everything is, but anyway. So we have the boundary, which is going to specify how values are divided in the body of the request. We can specify IDs after using for equals ID name. Wait. After using, oh yeah, the order doesn't matter if that's what you're asking. Yeah, the order doesn't matter. It'll look, the way all the elements are rendered, it'll find that element, even if it's physically lower in your code. Yeah. Yeah. Yes. Yeah. So I'll talk about it all in depth on Friday. So the question is, how come sometimes there's 4 dashes like in the header, and then there's 6 dashes down here, and then there's 2 trailing dashes here? What's going on with these dashes? The short answer is I'll get into all the details on Friday, but it is all on purpose. This is, I actually ran my server, built the front end, and this is an actual request that I got. I just deleted all the irrelevant headers. But yeah, these 2 extra dashes are intentional. It's part of the spec. It's in the RFC. You add those 2 extra dashes there, and then you add 2 dashes at the end to signify that that's the last boundary. But the 2 extra dashes are intentional. I don't think the web boundaries were necessarily intended to start with 4 dashes, but in any browser I've tested, especially Chromium browsers, they all start with 4 dashes. But if they didn't start with any dashes, this would make a little more sense. Instead of counting the dashes, we would just see 2 dashes and then the boundary, 2 dashes, then the boundary, 2 dashes, then the boundary, then 2 dashes. But with it starting with 4 dashes, it just gets a little awkward. I don't know. I'm sure there's a good reason, but I don't know why these 2 dashes are why they even exist. So we're going to have all of our values separated by these boundaries. Each boundary, each part of the multi-part request is going to have its own headers and a blank line and a body in the same format as the overall HTTP request, as HTTP requests. In the header, this content disposition, you're going to have the name, and you're going to have the actual values in the body of that part. And this boundary, the special thing about this boundary is that it's guaranteed, the browser's going to make a guarantee, and the protocol says they have to make this guarantee, that the boundary will not appear in any of the data, any of the content of any of the parts of the request. So you can safely split on the boundary. You can check for these boundaries, and you know you're not going to get like somebody who submitted the form with this exact boundary. It can't happen. If it does, if the browser generates a boundary, I don't know exactly how it does it, but if it generates a boundary that is contained in that content, it's got to re-roll that and generate a new boundary and get one that doesn't contain any of the characters in there. So this is generated in a way that is guaranteed to not be included in any of your content. So you look for those boundaries, and you know that boundary actually is a boundary and not just coincidentally part of the content. Much, much, much more about this. I'll walk through step by step all the concerns, all the everything about parsing this, because this is right from Learning Objective 1 on Lecture 2, on Homework 2. You got to parse this thing. Yeah.
Yeah. So would a malicious user be able to?
Nope. Oh, maybe. Yeah. If they actually formulated the entire post request. So the question is, could a malicious user put the boundary, mess with the boundaries? I suppose they could. Like, you could always create your own post request from scratch without using the browser at all, and then fire that off to try to mess with some parsing code. Maybe try to crash a server that isn't ready for that and isn't using exceptions. Yeah, I guess that would be possible. It would violate the protocol, but like the attackers don't care about that. They'll break any protocols they want. But they can't do that going through the browser. That's what I was going to say. A malicious attacker can't do that if they're going through the browser, because the browser is going to generate that boundary after it knows the body of the request. Or at least the content. It wouldn't know the whole body because the body contains the boundary. Just a few quick slides on this. Again, I don't just go through like all the thing, just like the last lecture on Monday. I'm like, here's the idea behind this HTML, CSS, JavaScript. Go to W3 Schools for the rest. I'll say the same thing here. Go to W3 Schools for the rest. But I did want to highlight two things because we see these so often on the internet. I just want to show you that you can build these things right now if you didn't know already. If we want to do radio buttons like this, make sure you have your labels like I was talking about. Here I do have my labels after my inputs. The order, the browser's going to find everything. And you put the value for each radio button, which should match the label, hopefully, so you're not just tricking your own users. And if you want the radio buttons to have the feature that we expect, where only one of these can be selected at a time, you give them all the same name. And then when a user submits this request, you'll have choose one as the name of your variable, and then either 1, 2, or 3, or empty string if somebody submitted without even selecting any radio buttons, of course. So give them all the same name, and you can have radio buttons like this. Drop-downs, if you want a drop-down menu, you have select, not input. I don't know why it's not an input. I'm sure there's a good reason. But select, the name, that's going to be the name, again, that you'll see server-side. And then all your options with values, and then some text hopefully matching the value so you're not deceiving your users there. So that's how we can do a drop-down as well. So if you want to do different kinds of inputs, there's tons of them out there, all the ones that you've seen, text areas, and in addition to the fields that we saw, and just whatever inputs you want to use. They're all out there. They're on, of course, I recommend W3 Schools, but anywhere else you want to go to find everything you want. Many more, search the documentation, find whatever you want to use. You can do all kinds of cool stuff now with what you know. So with that, that's my last slide. I have a demo set up for 8 minutes here. Given the snow, do y'all just want to leave? Let's do that.